Welcome to 3.1, an introduction to abstract data types. So, up to this point in this course, we've been playing the roles of class designer and implementer, but up to now, you probably have spent more of your career not so much designing or implementing things, but rather just worrying about actually what the functions that are built into Python do, more so than caring too much about how they work. In other words, you've been a client up until now. Now, some concepts are so general and so useful across problems that they transcend any specific programming language. Abstract data types, or ADTs, define a kind of data and operations that can be performed on them. As the name abstract might suggest, it is a pure interface, so there's no discussion of how this is actually implemented by a computer. That's what makes it abstract. By contrast, a data structure is a concrete strategy for storing some data. So let's suppose you wanted to store the grades of a class on a series of course activities. You could use an array of arrays. So if I copy this code here, we have the grades for Sadia, Yuan, and Elise are these numbers respectively. And if I throw these into my Python tutor, you also could, to make sure we know which column is which, we could say, we have a second array here that's got A1 for this one, the midterm for this one, just so that you have that. And if we run this, what we see is in here, we think of this as a list. It's a block of memory somewhere in the computer. But when we look at how does the computer actually represent this, it looks a little weird. And let's take a look just at that. So this is all just from that first line here. Grades is this stuff. And what do we have going on here? So grades is showing us over here we have a list, and the list itself contains lists inside them. Now, the way that the computer actually represents this is each of these arrows is an address in memory. In other words, when you go to access the grades variable, you don't get the whole block of everything that's there. All you get is just an arrow that tells you, hey, you're looking for stuff? Go over here. You go over here. Now, what are you looking for? You're looking for the 0th element, the 1st, the 2nd, so on. In each of those spots in our, in this case, array, and I'm using the word array specifically because a list is actually an abstract data type, but an array, which is specifically a contiguous block of memory in the computer, is a data structure. And so in this array that we have here, we have all the addresses of all of the other arrays that store the rest of our information. Now, another way that you could store the same information is a dictionary of dictionaries, right? So here we have our dictionary of dictionaries. Let's give this a shot and take a look at what it looks like. It's my first run through, so we'll see if this goes in the first take. Okay, let's see what we got here. So G2, just like before, only stores an address in memory. And when we go and follow that along, we can see, oh, we have our dictionary here, which is also an abstract data type that has the keys A1 and midterm, and each of these is also just storing an address in memory that lead us to our results here. Now, and these results here are also dictionaries, in which case they have as well keys and values. Now, you can probably think of other ways to do this as well, and there are definitely pros and cons of different approaches, but the whole point here is that ADTs are mostly concerned with what. What is the data being stored? What can we do with it? Data structures are the how. How is this data, like what you're looking at over here, actually stored in the computer? How do you implement methods in order to operate all that data and do whatever operations you need to do? And so this is the distinction that you need to keep in mind. We have to distinguish between the what needs to be accomplished and how do we actually do it, and being able to figure those things out is what makes you a computer scientist and not just a mere programmer. Welcome to Intro to Computer Science. Now, in this section, let's go over a few of the most common abstract data types that we've seen. Just like any other science, this is always debated. Sometimes computer scientists can usually at least agree on what the main abstract types are. Operations get a little bit fuzzier. People don't always agree on what are the operations that are associated with all of these data types. So here we're just going to stick with some of the basic ones, but there are obviously a lot more than are listed here. First, we have set. You can think about this like in math terms. A set is a group of numbers, each of which is unique. Or in this case, since coding, not just math, is any elements. It can be letters, words, objects, classes, whatever you feel like. Operations on a set include getting the size of it, adding a new value without putting in a duplicate, removing a value, seeing if something is in the set. Multi-set is just like a set, but duplicates could be allowed. So it's the exact same thing, but now you allow duplicates. A list, which is probably the one that you've seen the most of up to this point, is an ordered sequence of elements. You need to be able to access elements by its index. You need to be able to insert into a certain spot, remove something from a certain spot. Here you can immediately see there are definitely more operations that you probably would associate with list, but are they the most important ones / the main ones? That's where it gets a little fuzzy. Map, a collection of key value pairs, like a dictionary as an example. Each key is unique and associated with one value. Values can be duplicated. And operations are look up a value for a key, insert a new key value pair, remove a key value pair, update the value for a key. And iterable, a group of values, they could be unique or not, and you need to just be able to go through them one at a time. Most of these are probably familiar to you, maybe some you have not, even if you've never heard of ADTs before today. So you've almost assuredly used Python lists, Python dictionaries, but there is an important distinction between the way that Python does these and other languages. So in terms of Python allows a list to be a data structure. It has a way to represent in memory, as you can see over here, how a dictionary can actually go into the computer. But this isn't true of every language. And so in Python, there are concrete implementations. In another language, that may not be the case. So the designers of Python specifically decided, we want to actually have it so list is a data structure, unlike its normal definition of abstract data type. So a Python dictionary, and here we literally have it with the Python font highlighting whatever. So DICT, in terms of Python, is itself not an ADT, but it is fair to say that a dictionary is an implementation of the map ADT. But there's usually no one-to-one for these. I was talking about arrays before, a contiguous block of memory, as one way you might represent a list. But that's not the only way to do a list. There are other ways to do it. So there's never a one-to-one correspondence between this is the ADT, this is the data structure. You can implement things in all kinds of different ways, and this isn't just a Python thing, this is any language that you can think of. Now, a single ADT can be implemented by a lot of different data structures. So list is an implementation of the list ADT. You also could implement a list, like the way that we think of a list, right? You have a bunch of things in order. Each one has an index, and you can use the index to get the value. Just conceptualize that and that alone, ignoring the fact that Python has a meaning of the word list. You could still get a list to work in Python using the Python DICT, dictionary, in which each key is the index of the item. So if you have 3 elements, hello, 42, goodbye, you just set up a dictionary where it's 0 gives you hello, 1 gives you 42, 2 gives you goodbye. This is a Python-specific implementation of DICT, which allows you to implement a list with a capital L abstract data type. So Python dictionary, data structure, implementation, list, abstract data type, way that the data is actually stored. On the other side, each data structure can also be used to implement multiple abstract data types. So a Python list can be used to implement the list abstract data type, but also all the things that are up there as well. You could use a list to implement a set if you wanted to. Not too hard, you just have to add a few little features to it. So think about how you would do that. Most importantly, how do you avoid duplicates? Dictionary could do the same thing for any of the abstract data types that I mentioned. And this is going to be true for the new data structures that you're going to learn in this course. Just a quick note, beginning Python programmers often implement sets with a list, But it turns out Python also actually has a set class that implements the set ADT. So if someone asks you like in the workplace, hey, can you like write some code to do a set for me? You just steal the Python one. It's already there for you. We've said that, I've said, that each ADT is so general it transcends individual problems, programs, languages, and in fact the ADTs up above are implemented in other programming languages to different degrees, depends on the language. While the exact data structures used to implement them vary significantly from language to language. In fact, Python is actually very specific about weirdly having something already in place for the list type. A lot of languages, you either need to bring something in or may not even have something for that. That said, these abstract data types form a common vocabulary. In order to be a computer scientist, you need to understand this basic vocabulary.